Oh, okay. Now I think since we are recording, so we can start here. S- Suppose we have a like invoice generating system. So I always try to give an example. So this is one example that uh, we want to build an invoice generation system. So suppose we have the feature there actually mm, add creating a new invoice, design it, save it, share it to other people. Suppose everything is working there. One user comes in, uh, find out that everything is working. They prepare their invoice, send to their clients. Everything is fine. Now, when your user base increases, there can be some users who are using third-party CRM like this. How your application will support that? We actually know like how we can actually support that, but let's discuss again about that. We need to have an API server. What API server will do, it will communicate in a way that machine can understand. So CRM can understand that, okay, I want this kind of things and I get this back as a response. So we don't need to create API like in every system. If we don't need to discuss, like have the communication with CRM or any other system to our application, we don't need API. So we need to understand that when user base is smaller, only one type of users is there, they are like manually logs in and do things. We don't need API. When we need API, when we need to communicate with other systems. So when we come up with the formal definition, API acts as like bridge that allow different system to communicate and exchange data, and definitely regardless of the underlying technologies. Why I put this information in front of you? Because normally what happens is when we come up with the system designing part, we just throw this term that okay, we'll build API for this, API for that. But do we really need API or not? When we see that we need to communicate with system, then we need that. And even if we throw the term that API, we will build some API, but we need to know like what kind of API we need to use. There are a lot of different kinds of APIs. The different kinds of protocols are there. Which one is the best fit for which system? So we'll go through these different kinds of APIs. Let's see. The basic structure is like we will have an API server, we'll have some consumer and requester. You can say that. What consumer will do? Consumer will send request and they will get back the response. And normally what happens, this is the RESTful API we normally call it, like everyone knows about RESTful APIs, but there are different types of APIs as well. There are like SOAP protocols. SOAP protocols is actually kind of outdated, but still there are like a lot of places we use SOAP protocols, especially legacy systems. We'll go through all those part, but apart from REST, we also need to know about SOAP in order to communicate with other systems. Just let me, and another one, the new one, that is GraphQL. It is similar to REST, but it has some benefits that we will discuss as well. So we can see that there are like three types of request and response protocols, and we'll go through those. Apart from that, what other we can do, we'll discuss. So let's see like how SOAP works. The basic structure is like this. Whenever we have like two parties, one is SOAP sender and another is SOAP receiver, and it goes over HTTPS. But always you need to think of an envelope. Always it sends the message inside an envelope. The request will be sent over an envelope and response will also be pass through by an envelope. Envelope means there will be an XML format that has the envelope part. Let's see how it looks like. So here is an example. Last day we discussed about the weather API. So I just put that example here. So if you see the first line here is the SOAP environment envelope. Here define the like namespace and how it should be designed, how the XML will be designed. It is well defined. And if you need to pass the request or get the response, you need to follow this schema. Otherwise, the SOAP behavior will not work. So when you can use this kind of protocols, when you use like enterprise applications, like banking and financial system, you will find this kind of systems. So if you want like secure communication, SOAP has built in security, WS security, and you can use that healthcare system definitely use that one. Like still there are a lot of healthcare system they use SOAP, and there are some stateful operation compared to REST. SOAP has some built-in state management system, so you can also use that. Whereas REST is the most popular one, and how it works. Even if you know, probably some of you doesn't know about that. So for the benefit of everyone, so SOAP has HTTP verb, like what kind of action you are trying to do, and what will be the URL. So you can see there are like I just put like 4, but there are more like get, post, delete, and put. There are like patch as well. So when we say like get something, that means I want to get a resource. I get that URL, send the request either using Postman or using car, send the request, and server send back the response usually in JSON format. So that's how REST works. So request comes up like this, like in the get, we need to define this HTTP verb. Then what resource I want a user like 1, 2, 3, and then I can actually say that what is the host, what is the authorization and content tag. And response wise, there are like two parts of the response. One is the status, like whether it is 200 or not. 200 means like it is correct. If it if I send a request to create a user, it's supposed to send 201 that created the resource. So this kind of things is HTTP status, and then along with that, response comes with JSON payload. That can be like this: ID, name, email, role, created at, whatever we define, we can get this response. This is how REST works. So REST, if you want to know about the use cases, like most of the cases, I think probably 90% cases, all the new system public APIs are in REST. Twitter API, GitHub API, all are in REST. Uh, Simple microservices where we communicate with normally one API server and multiple services. So we use REST. And for mobile application, most of the mobile application development, they just send request to backend and following the REST API. Now this is the interesting one, GraphQL. I'm not sure whether you guys are already familiar with it or not. Probably you already heard about GraphQL, but maybe you never used. So I'll give you some example and what will be the format of this one. GraphQL is like a fascinating way of getting data. That's the main actually reason why we use GraphQL. So normally what happens in REST API, let me show you the how GraphQL request and response. So in the GraphQL, you define what kind of data you want. Earlier in REST API, what happens that you send a request that I want to get the user, but you don't define that what are the information you want from that user. It is the server's response that okay, you want user, I'll give you all those publicly available fields. But in order to save the bandwidth, you can use actually in a different way in GraphQL. You can define that okay, I don't need all those information. I just need ID, name, and email. Just give me these three. And GraphQL get those information and give exactly what you are looking for. So now we can go to the part of use cases. Normally what happens like when you have like complex client application, you want user information, notification, a recent transaction in a single request. What you need to do in REST API, you need to call always like, okay, first request for user information, second request for notification, third request for transactions. In GraphQL, you can actually define that, okay, from user, I want this information, from notification, I want that information, recent transaction, I want that information. You define this schema, send it to GraphQL. GraphQL server will parse those data and return you back. So complex client application with single request, you can get the data. So the benefit I already mentioned about that reduce overfetching and underfetching. So REST API always pull either more data or less data. So you need to call again to get more data. For GraphQL, you don't need to do that. It optimizes network uses. And one of the most important one is when the mobile application with limited bandwidth, they actually don't want all those bandwidth to be used for unnecessary data. So that's why GraphQL is very much popular there.
There is a Farki, there is a question.
Yes. Okay. Let me just check. SOAP came with some state management. Can I use it, for example, to cache query results used for pagination so that subsequent request will not be queried? Okay. So there are like two questions. So let me go one by one here. SOAP actually can do that. Uh, SOAP, SOAP has the built-in state management part that, okay, you send one request, it keeps the information, okay, and it in which state it is remaining, you can understand, okay, it is the page one. If I want to send the page one, then page two, page three, it can do that. Or state of the request wants to get one data from one place, wait for it, go to another one, get data. So it can do that according to it this protocol. REST API is stateless, so REST API don't do this kind of thing. REST API sends another request. So we can use that one. And second one is, okay, why hasn't GraphQL become the de facto standard for apps and RESTful? Are there significant downsides? Yes, actually, GraphQL supposed to be the like de facto standard, but managing GraphQL is a bit difficult. There are a few things you need to what do you call? You need to balance. Like if you use like one API request, like one URL for all kinds of data, that means you need to maintain all kinds of overhead with that. And like pagination, mutation, it has like new terms for that. So that's why GraphQL is still in the process of becoming de facto standard. But like for me personally, I like GraphQL. So I believe that over the time GraphQL will be the like de facto standard when GraphQL will be more mature. A bit complexity is still there.
Thanks, Forky.
You are welcome. Okay, let me just little bit. Let me show you a little bit comparison here. Uh, SOAP, REST, and GraphQL. So SOAP is rigid. We know that we have a fixed contract there. REST is actually limited by endpoints, and GraphQL is highly flexible. And performance-wise, I would say that it depends. GraphQL is definitely the most efficient. Sometimes REST is like overfetch or underfetch, but performance why okay, SOAP definitely has like more data to send. It sends the envelope as well, and it is in XML format. So that's why SOAP is the popularity of SOAP is declining. Security wise, built-in standards. REST wise, you need to custom implement that. GraphQL has same thing. Ease of use, complex setup, easy to implement. The rest is like easy to implement and requires GraphQL requires learning curve. That's another point where you mentioned that why it didn't become de facto standard, because GraphQL you need to learn more than REST. REST is simpler than GraphQL. And statefulness wise, REST and GraphQL both are like stateless. SOAP can be stateful. And transport protocol wise, all of them are like all of them uses HTTP protocol, but SOAP also can use SMTP protocol. This is the comparison of these three: SOAP, REST, and GraphQL. So most of the cases we use REST API. GraphQL is a new fantastic way of getting data, so you can use that. Now, I would like to tell you about the like what do you call most amazing feature of uh, gRPC. gRPC is also another way you can actually communicate from one system to another system. gRPC stands for Google Remote Procedure Call. Google has coined this part and developed by Google based on HTTP2 protocol, which allows for feature like multiplexing, streaming, efficient binary serialization. If you are looking for performance part, you want to send more data to in one channel, that's multiplexing. You need to send stream data, you don't need to wait, you just send data, send data. That's streaming. And you need to serialize those in a binary format so that you are don't need to spend time on compiling JSON to binary. So all these things are in gRPC, a bit complex, but if you are working in a project that requires performance over like development friendliness, then you need to use gRPC. So let me just give some example on gRPC. There is like people don't get much chance to study or use about gRPC, so that's why I just put a bit more about gRPC architecture. gRPC is, people say complex, yes, complex, but there are only these four parts. One is client, another is server. We know this part. Client will do like request creation, method invocation, and server will do request handling and response generation. So this one everyone knows like normal way, but how gRPC is different. gRPC has a stub. That stub actually it can do both way, client side also server side. So it will remain in server and remain in client, and it will run a procedure of that server according to the request. So your entire part will be like uh, kind of native communication. It looks like native communication, and all this information like we define in schema, we call here as service definition. We specify the method, we specify the protocol buffer, and how actually it is implemented. You need to first define the service. Okay, I want to call this method, and this method will do these things. Define service and message. Okay, what message you are going to send? Generate stubs that will actually run this. Run this. Sorry, invoke the method. So if you add the server logic, then the last one you need to do like invoke your method. So this is how gRPC works. This is the basic one, but gRPC actually supports all kinds of language. Not all, like most of them, like Python, PHP, Java, every language. If you use gRPC, actually you can get high performant communication. So these are the use cases like I would like to share that Google services. Definitely Google discovered this part, developed this part, so definitely Google will use. But Netflix, while streaming and using their microservices, they need high performant communication. So they use gRPC. Square, one of the most popular uh, site where they process the payment, and they use gRPC. Uber, efficient communication on larger scale microservice architecture. The between all the microservices, they uses gRPC so that it, it, it is performant. Is there any question about gRPC or something, or any other API calls? Yeah, that's true. Discord also uses it. It is something. What is the performance boost over REST SOAP and GraphQL? Are we talking 10 millisecond? It's around that. Actually, not 10 millisecond probably. It's probably 50 millisecond around that. But I have gone through the performance benchmark, but I cannot remember exactly. But it's around like 5 to 10 times better than REST API. So I would say that if whenever you need this kind of performance, this kind of services, gRPC is the best option for you. Right. Yeah. If a bit the learning curve is a bit higher. Setting up the proto buff is a bit complex, but if you do 2-3 times, I think it will be easier for you. So we learned about like different services that communicates each other, can use different protocols. Now we know that like okay, this is the way we communicate with each other, and there are like one service communicating with another service. Like one point is the requester, and there is server. But there's sometimes when we have like microservices, like one service is communicating with another services. How it may look like. So suppose this is service one, they send request, sorry, to service two. So this is the normal scenario. But in real life, normally we don't have like only two services. We have multiple services. Suppose there is service three, it has dependency with service two. We have service four, is dependent also service two or something. So this is how it grows. Normally in real life, when you have like a lot of microservices, you will see this kind of diagrams or this kind of request and response dependency in multiple services. When there are like a lot of services that are interdependent, here interdependent, which is actually a bad thing. We know that we need to decouple our code. Same in the same way, we need to actually decouple our services as well. If services are dependent to each other, that means if one fails, everything will collapse. And we don't want that. If it is not totally, uh, there are two parts. Like one is if it is an independent service and there is nothing to do with another service, we just send any information there. It shouldn't die if other service dies. Let me give you a e-commerce example here. But okay, this is the name. Like how we can solve that. That is event-driven architecture. But let me give you the uh, an example here. So I think most of you guys familiar with e-commerce system. We use Amazon or any other services for that. There are like order service, billing service, shipping service, inventory service. Suppose one user orders something, we need to send bill to them. So that's the billing services job. Billing service need to say that, okay, there is an order, bill is done, you need to ship it. Shipping service also sends the information to inventory service. Say that, okay, I want to ship this one, inventory should be updated. So this is how it works. But if inventory service dies, then the process stops there. Like, okay, I cannot actually complete my entire circle. Although billing service is kind of independent, it has nothing to do with inventory service, but it will say that, okay, it will impact to all of them. I cannot finish my process. So it is dependent to each other, which is not we want to keep. We want to keep it independent as possible. How to do that? We know that we need to make it like event-driven architecture. How it will look like? It will look like this. All the services has one thing here is event broker. Event broker is something that will route all the information. Okay, something happened. You want this information to go to billing service. I will send this information. You don't need to think about that. So that's the event broker's job. It will make others independent. So all the services are now not dependent on each other. It just said that, okay, my job is done. I am sending this information to event broker and I am telling event broker that which service you are going to send. So event broker's job is to send that data. So all other services remain same. And it is not dependent. If something is dead, event broker will wait or event broker will have its own process to recheck and send data to that service. When service will spawn again, it will actually get that, okay, I have few data queued up, let me get those data and process it. So first service will not wait for other services to be like alive again. So let me just go in deep here. So whenever we think about this kind of event driven system, there are like two parts as well: event producer and event consumer. And in the middle, there are like event broker. But there are like different use cases. So we cannot just use same way for every kind of system. So if we have only two services or three services, whether we need to use Apache Kafka or not, whether we can use SQS or not. So what kind of services we will use depends on what kind of system we are dealing with. So let's see what are the types of implementations there. There are actually three types of implementation. Whenever you are thinking of event-driven system, you need to find out which type is most suitable for you. Like whether it is a point-to-point messaging or PubSub or event streaming. These are the three parts. Actually, it will cover most of the cases. So how it works, suppose you have only one sender and one receiver. There can be like similar setup for multiple services, like one sender, one receiver, one sender, one receiver. All of those can be implemented in a way that you can only have one queue, and your event-based system will be ready for that. So sender will send all the messages. You can see M1, M2. It will go to the queue, and this queue will be processed by receiver M1 and M2. It will not send any response normally. It will just send the acknowledgement that okay, I have received this one. So this is how the message will flow if it is a point to point or peer to peer communication. So event driven simplest form is this one. And now the second one, this is like kind of most of the cases we have and our use cases. If it is not a data stream, then this is the case. What happens here? So there will be like one service that publish information, and all other services will just receive that. So one example I can give you, that one I will actually discuss about that, about tournament management system. Suppose you are in a match, or yeah, you are in a match and you are a scorer. You want to update the score, and you want this information to be broadcasted to all the audiences in their app. They will see that okay, the score updated. Suppose it's a tennis match. Okay, it's 16-4, now 16-5. What is the score? So all the people will see that. Same thing for other services as well. One publisher and all subscribers. So if you want to have the same system for multiple matches, so what do you have? We have multiple publishers and multiple consumers. And according to the subscription channel, they will get the score. So this is how PubSub works. PubSub, like Google has its own PubSub service. Apart from that, there are a lot of PubSub service. If you want to like get a free one, that's like I tried with ABLY. So Ably, they are actually giving you some free credit, so you can try it out how PubSub works. Now the third one. Third
Turkey,
one
there is
is
a question.
okay. What happens when event broker dies or slows and becomes unresponsive and loses events? Usually, when it happens, we actually keep the uh, queue, dead letter queue. We call it dead letter queue, or you can actually dump it into other places, maybe in data lake or other places, and you can replay. If event broker dies, you can actually, when it gets up, then you can actually replay those. So all the events, if you lose the event, actually normally event goes, so you will not find it. So what we do actually, whenever event comes in, we keep it in a log. So like it has a format. If you know about cloud events, there's a website called Cloud Events. They have the format of any event. They have like standard of the formats. So whenever it goes to event broker, before routing it, it actually dump it to one place, either dead letter queue or any other places, and then it routes. So if it dies, it actually stay there. Now you need to check why it is dead. You need to ensure that it is up again. When it is up, you can actually say that okay, replay all those events from the dead letter queue or some other places wherever we dump it, and it runs. So that's how we prevent some loss.
Thanks, Forky.
All right. Okay. So we have gone through all like three kinds of event-driven architecture. It will be complex when we draw this diagram. Oh, sorry, I think I missed the event stream part. So this is similar to PubSub, but here data doesn't come in a normal way. A lot of data continuously comes in. When a lot of data continuously comes in, normal services cannot actually handle those. We need to store it in its own queue. So that is, we can use Apache Kafka, or we can use any other tools, but Apache Kafka is one of the best tool for that. Whenever event streams, it actually get all those information, keep it stored, and it sends data to like mapped service. There is a map definition. We can put the map definition that, okay, this kind of data topic, they call it topic. If the topic is this, send it to service 1. Topic is that, send it to service 2. This definition, when you put it there, your Apache Kafka event stream processor, they will actually send this data, and it will store the data. It will send a copy of that data. It will not lost. Normally, that's why Apache Kafka, when you put it into AWS, a bit costly, but that actually ensure the data is remain there, and one data can be published to multiple services. So all PubSub feature is already there, and also it can manage the event streaming. So these are the three types of event streaming. So when you do the event-driven architecture, you can choose according to your need. Like if it is like only two parts, two services, then just use one queue, done. If you don't have stream data, use PubSub. If you have stream data, use is dedicated server for processing stream data. Okay, I need to slow down now. Do you have any question about event-driven architecture or anything? That's a good question. What are the missing pieces from GCP's PubSub comparing to Kafka? It's almost same, but for the event-driven part, for the streaming part, like when there are a lot of data comes in, Kafka has its ability to actually store those, process those, and route those. PubSub is actually not built for that one. Streaming data is the only part that makes the difference. But recently, probably PubSub also has this feature, but I'm not sure of the recent development.
If Forky, I just want to ask, if you are given an option to choose between Kafka and the Google PubSub, which one would you choose?
I will use Kafka because it has the ability to both like normal request and streaming data. So whenever we have like monitoring data, mostly we will have like monitoring logs, then definitely we will keep Kafka as the best option.
Thanks.
You're welcome. Now this is something cap theorem that is actually very much popular in terms of understanding what we can actually give when we okay, let me just make it in a nicer way. When we build a distributed system, we may think that okay, we will give everything, we will make the best one, but we need to understand the limitation. When we design something, we cannot actually give all those. Let me tell you here. If you want consistency, that means all clients will see the same view of data even right after update or delete. This is the consistency. And availability. All clients can find a replica of data even in case of partial node failure. And partition tolerance. That means if the network fails in between, it will still work. You can get only two. You cannot get all three. Let me give you some example that it will be easier. Um, Normally, what happens that when your CEO will ask you that, okay, you are the system architect, build a system and that will have everything, consistency and availability. You need to trade off between those. Okay, you want availability and partition tolerance. You need to sacrifice the consistency part. You don't need to sacrifice like totally consistency. You need to go to have you need to have like eventual consistency instead of strong consistency. So this trade-off discussion you need to do with your stakeholders. That's why this cap theorem will help you. How it will help you? You need to understand the problem first. Suppose user one check the balance and found that okay, in database one balance is 500, even in database two balance is 500. That means it is consistent. But when user spent $200, database one gets okay $300 because 500 minus 200 is 300. But in the meantime, same time, if you look into the DB2, the balance has not been updated. It is that means it is not consistent that time. It is inconsistent, which is not expected. In financial parts, we don't want that. We want to have like all the database must have like atomic process. It will go there, write exactly same to all replica. Then we will say that okay, it is done. Otherwise, it is not done. Transaction is not done. And availability is something that is okay. Even if you have like wrong data, like normally what happens in the like in YouTube subscription that okay, some people has like 700 million e- subscrip- subscribers. If someone else just look at that same person and found that okay, he has more than that, it doesn't matter actually. Eventually it will be consistent, but we want to keep it available first. So different different scenario, you need to build system in a way that even if it is not consistent, is okay. If it is available, that is the most important part. A partition tolerant is something that is actually if there is the network is not working, still it works. So actually that is kind of impossible part. When you have the distributed system and in between, if the network is not working, it normally doesn't work. It is an imaginary part. So you can have like CP, consistency and partition tolerant, like financial transaction. Like in MongoDB as well, you have the replications. It is all the time the data is consistent because it will check the heartbeat and make sure that the data is uh, identical in both secondaries and primaries. But in social media part, you can have availability and eventual consistency. like this person has 923K subscribers. But if you see that it is 924K, it doesn't matter actually. But if the site is on, the data is there, people will be happy. So for this case, availability is more important than consistency. And this one is actually unrealistic for distributed system. If you have distributed system, then partition, all the partitions need to be like connected. So there's like one comparison table here. If you want to know that like strong consistency or eventual consistency, what is the difference between that? Normally, strong consistency latency is high, because when you send a transaction request, it first go to the first database, updated that, second database, update that, everything goes fine, then it comes back and say that okay, it is done. On the other hand, in eventual consistency part, latency is low. It will update one database and say that okay, it is done. Then behind the scene, either batch processed or event based system, it will update finally in all the places. So that's why from the user's point of view, they will say that okay, this network request went there, come back very fast. Availability wise, limited during partitions, but eventual consistency wise, it is highly available. And data freshness is immediate and delayed, and complexity is low, and eventual consistency is high, because you need to have like behind the scene process that will get the data and make sure this data is the latest data and update all the places, all the servers in different zones. So, so these are the differences between these two consistency types. Why do you need actually this cap theorem? Mostly you need to discuss about the trade-off part and make sure that your system is either available or consistent. So that's why you need to know this theorem, and you need to advocate your design to the stakeholders with this theorem. Okay, like I have got like two questions here. So complexity wise, why eventual consistency is high and why strong consistency is low? Okay, complexity in terms of implementation of that design. Suppose you you want to keep it consistent. It's actually you don't need to make it consistent by yourself, because most of the databases, when you make partitions, sorry, when you make replications, what happens? Database has its own way to communicate with all those. As you see in this MongoDB part, like if there are like 300 servers replications, it will check the heartbeat and manage those. So when we implement this one, like okay, I want to store a data, it sends the primary, then database will handle all the replications and manage this one. So you don't need to actually think that okay, it is there or not. And if it fails, if it cannot actually reach all those, cannot make sure that data is consistent every part, it will die there. Like it said that okay, it failed. So you need to send again all the requests. So that's the way you need to send. But for availability part, you send data to one database and say that okay, it passes. Then you need your event, probably you triggered an event, and that event will traverse all the places. Now it also need to check someone else from some other database they have updated or not. If they updated, this is the latest one or not. If I am updating, am I updating the right data or not? So that's why it becomes complex. There are many things you need to consider when you need to make eventual consistent. Oh, okay. Since we learned about cap theorem and event driven architecture and APIs, now we'll actually practically do one thing. Yeah, right. Marco actually had a point here. So the clarification on the partition tolerance, uh, you mentioned the unrealistic in a distributed system. I imagine a fiber cable cut linked your DB shards can be severed and fixed later. Okay. When it is fixed, the DBs can then be synced. Exactly. So suppose fiber cable cut, and in zone A we have 1 dB shard, and zone 2 we have another database. Now if we send the request, okay, from you want to get the data from zone A, we'll get like $200, and zone B it will send like $500, and it is always inconsistent because the fiber cable is not there. When fiber cable is ready, then it will work again, but when it is not there, it is always wrong. It will not send the right data. Not even eventually consistent wise, it will not send the right data. Not strong consistency wise, definitely wrong. Eventual consistency also it will be wrong unless the network is again alive. That's the same thing I pointed actually. So when it is alive, in reality, when it is alive, we know that okay, it is alive now. It is time to sync. It will sync. Good questions. Actually, I really appreciate this kind of questions. Okay, now when you need to design something, how you will actually approach that we will do. We will design a system together. You can say if you have your like tools ready, you can draw together. But normally, I will do it, and you guys can participate there. So in a practical way, either you are in an interview or you want to build a system, so you need to follow the similar steps. In interview you need to follow the step in 45 minutes or 30 minutes. For in reality you will get like probably 2 3 days or weeks for that. Okay, one question here there. Sorry about the event streaming. Is there any framework that work with Kafka to help implement back pressure control on how fast the producer send data when the consumers are overloaded? Mm, actually, practically, I haven't used that. So sorry for that. I haven't used that, so I cannot say that. But definitely, Flink is one of them. But I haven't used that, so can't say much about that. But that's a good question. Cool. Let me start this one. First thing, we need to clarify what is tournament management system. Suppose, how can we scale app which has the WebSocket? That's another good question. If we have WebSocket, scalability wise, actually, we need to understand like how WebSocket works. That's a good question, and I think when we design this diagram, I will um, actually touch that part. Let me proceed with that. I will come back to this question. Okay, so because in this tournament management system, we will have the WebSocket kind of things. Let me just go through first here. So design a tournament management system that supports managing tournament for various sports. So suppose we talk about tennis or badminton, where we have like team registration, team scheduling, score update, leaderboard management, and the system should handle millions of users across different regions while ensuring high availability and data accuracy. That's what your stakeholder will give you. Like you want to get this project, the project manager will give you this one. Okay, I want this kind of things to be built. Now it's your job to clarify whether it's million of user or not, what kinds of users are there, and all the questions you need to ask. As a system architecture designer, you need to do that. Now, what are the things you will discuss and communicate? So suppose you have communicated with them and discussed that, "Oh, okay, user management, do we need that? Definitely, probably need that. Tournament management, yes, we need that. Match scheduling, we need that. Participation management, score management, all of those like notification, live streaming, reporting, payment processing, all of those are functional requirement. So that means these are the features we need to have. Probably these are the multiple systems or one system maintain everything, but we need to come up with the high level services. Okay, we want this functional requirement is definitely the first thing you need to list out. But as a system architect, you need to also get the non-functional requirement, and you need to calculate accordingly. Okay, you said millions of users. How come? Why do you think at the very first time it will have millions of users? And what kind of users will be the millions of users? Who in which service they will use? This kind of questions you need to ask. So first thing you need to ask, if you attended last session, use use case diagram is one of them that we need to use. We need to know the actors, like what kind of users will use this system. You need to ask the question to the project owner. Okay, what kind of users you are expecting? Admin, who will manage everything, all the tournaments. You will have players. Do you want to register players or not? You need to have team managers who will manage the players, or maybe if there is like individual player, they can just log in. You need to have a scorer who will update the score. You need to have spectators who will see the scores. They will probably they will not worried about what is the tournament's length. That is the admin's part. So different people has different expectation from this system. So we need to first figure out what are the types of users we are dealing with. Then we come up with, okay, now which services are connected with which type of users. So we have seen they are like user management, tournament management, match scheduling, participant management, all those features. But at the bottom, you can take a look: admin, players, team managers, scorers, and spectators. So all kinds of users are there. Now you need to find out, okay, user management. Who is the mainly responsible person? Who will use most? Probably everyone will use, but who will use most? Admin. Admin probably use that user management most. Tournament management, admin will use that. Mass scheduling, probably admin will use that. Participant management. Here team manager will find out, okay, player one, player two, player three, these kind of players will be in this team A, in my team. So they will manage those. Score management. This is the scorer's main job. Scorer will go there and update the scores of those matches. Leaderboard and statistics. It will probably automatically generate the leaderboard, but spectators want to see the leaderboard. Who is on the top of the table? Team manager also need to see the leaderboards. So there will be many services that multiple type of users will use. Notification. It is actually everyone will use that. So I just put 2, 3 in there. Now, live streaming or updates. This is the most important part for spectators. They will do the live streaming and updates. Reporting. Reporting part is for the players. Player want to see the reports. Okay, what is my stats? Team manager also need to see that one. Payment processing. If we have something for payment processing, we can have for everyone. But I'm just putting it for the sake of just showing here spectators. Probably a spectator will buy something through through your app. So these are the mapping of the functional requirements. So now you know that which user will do what. So which services need to scale, which services is okay if we don't scale. So we need to understand that those part, and how much effort we'll put on which system, that also we can calculate. That calculation is called uh, back envelope calculation. So this back of the envelope calculation wise, you need to assume things. You need to ask questions, and as in, okay, probably how many 10,000 users will use. So you need to ask some questions there. Give me 1 minute. I need to drink some water.
Well, Faruqi is away for a minute. Any question from anyone? Paul, how is it looking so far if you're here still on the call? You can unmute yourself and talk if you need. I was saying that everyone can unmute and we can have a chat.
Yeah, thanks for doing this. It looks a really good course so far.
No problem, Nicholas. We have one more session coming on system design. This is the last session. I think it's next week, Monday. And I was also thinking about starting a series on DevOps. So if you're interested, if you think DevOps is interesting, please just give a thumbs up in the chat. Uh, I personally would like to learn more about DevOps, so I was thinking about inviting someone very knowledgeable, and then maybe ask questions and learn from the person's experience. Awesome. Looks like a lot of interest.
You do these sessions every week, and it's just a different topic every.
I tried. It's been I think last few months. It has not been. I mean, there has not been a lot of sessions since I was a little busy. I'll try to start. Try to be more regular going forward. And after the system design series ends, then we can. I'll try and see that we can start a series on DevOps. Awesome. Farooq is back.
I'm back again. Okay. So where we were here, back of the envelope calculation. Suppose now you are the system architect. You first need to ask, like, okay, you want to start this tournament management system to how many cities? Because definitely they will say that, okay, I probably worldwide, every cities in the world. Then you need to ask more question about, like, if you think about worldwide, that means you are thinking about different languages. Do you really want like multiple languages to start with? Then they will come up with, oh, no, probably start with only Canada. Okay, only Canada. Then you need to come up with that, okay, you need to do some marketing there. According to your plan, you need to go to the communities, send this information that you are going to use this, you are going to develop this application that will help the tournament management or players or everyone. So are you going to use your marketing costs into all cities of Canada or not? So this is the question when you ask, then you will see that, okay, that will actually come up with maybe 10 cities or maybe 50 cities, whatever the city number is it will not be the like entire world. So you need to specify with more and more questions. Then they will say that, okay, we want to start with 10 cities. When they will say like 10 cities, then you need to assume that, okay, in one city, how many communities will be? Like suppose one badminton tournament, um, maybe in one community, one badminton tournament. If there are like multiple communities, multiple tournaments. So you need to understand that in one city, how many, on an average, how many communities there? Before building anything, if you know this one, then you know that, okay, there will be like maybe 50 communities per city. It's on an average. It is not the rigid one. This is like back of the envelope calculation. So you assume things. So you come up with, okay, 10 cities, 50 communities. So that means every community, there will be one community leader, one admin who will arrange this kind of tournaments. So total number of users will be like 500. There will be only 500 admin users. So all the services that's independently needed for admin, you just need to scale up to 500, not more than that. So that's the starting point. Similarly, now you can calculate that, okay, how many players will there be? So how come I have come up with 50,000? Can anyone tell me? Like if you look at this one and you see other parts, anyone wants to try something, type something? $1,000 per city. Yeah, that's also true. Okay, just take a look on the uh, team manager. So what I said here, the number of team managers. Suppose there are like 500 communities, and each community has like 20 teams. Then there are like 10,000 teams. And in one team, if there are like 5 people, that means it's like 50,000 players. So that's how we can calculate that, okay, how many users will be there, how many players will be there. Scorer. Scorer probably for one tournament, maybe 5 scorer can cover all the matches. There can be like 40 matches, but 5 scorer can cover this. At a time, probably 5 matches. So this is how you need to assume something and make the number. Okay, 2,500 scorer will be there. But if you look at the spectators, now you think if there are like 1,000 community member who will watch this one, and there are like 500 communities, then there are 500,000 spectators we are expecting. That means definitely when we talk about scaling, we need to think about um, spectator service, like what service a spectator will use, that needs to be scaled up to 500K. But others are not that much. Like team manager, probably 10,000, player 50,000, but for admins, there's very less. Scorer, very less. So we don't need to scale all those services. We need to scale spectator definitely, then player, then team manager. So do you have any question about this back of the envelope calculation? How to ask or anything? Okay. If there is no question, then actually we can keep this information in our head and start drawing. So let me share my screen and I will start drawing this part. Draw.io. I'm going to draw.io. Share this tab. So if you already have logged in, you can use that as well. So let me just do it here. I'm taking the blank diagram so that it remains tournament. Okay. So first service we have seen is like user management part. It is actually for everyone. So we are not going to build everything now. Now I'm just showing the basics of some of the systems, and we'll go deep into multiple systems. So let me just put something here, the user management, like user management service. This is a service that probably will have some data, and its data will be in the database. So in this part, you can actually look for database. There will be multiple icons. You can use any of them. Just I'm taking this one. So user management service, that can be, if we don't scale this up, this will be the basic implementation of user management service. If we can just put like user here, and probably we want to use this one as an admin. So admin will use its probably either mobile or laptop. Just for the sake of drawing, I'm putting a laptop here in front of admin and use the browser and go there. So you need to be handy with this part so that you can actually easily draw this kind of diagrams. So uh, similarly, we can actually have tournament management system where you define that, okay, when the tournament will start, what will be the venue, how many matches will be there. So it's actually quite simple, and if you don't need to scale, it's okay. Now this one, if we want to keep the tournament and team together, we can use this one here for the team managers. Either we can have different system here, or we can use the same one. Just for the sake of simplicity, now I'm keeping it as separate system, like participant management system, participant management system. Same thing, we can just copy paste here. System design is quite easy unless you want to scale this up. So user management service wise, now there will be more things, but for this part, user management service can be a third-party service like Okta, or there are other services like AWS Cognito. So it can be a third-party service which maintain everything. Admin may not, you don't need to build this system. You can use this kind of services. But as a system architect, you need to decide whether you will build this one or you use third-party system. For tournament management service, that is the like core one, you need to build this one. Participant management service, you need to build this one. Now there will be a complex part, but let me just go through this one. We have like a scorer. So let me make a scorer here. What a scorer will do, a scorer will go to the match. A scorer, suppose he or she will use mobile just to score this one. Now, what kind of system he needs? He need to have like score management service. He also need to know about tournament management service. So now there will be different kinds of services and it will communicate with different things. Score management service. And it definitely needs to communicate with tournament management service because tournament contains all the matches. And this one, if there is any question in the chat, please let me know. I'm not looking at that. So since it's a microservice, we can think that we will have different data sources as well. We can keep it same as well. So it depends on what we are building. For this one, we can have actually different data source. We can actually have same database as well. Both are okay. Like this score management services, it will update the score and put it into database. If we want to keep in the same database, we can keep it. So for this one, we can say that, okay, for the simplicity, I'm using this one. Now, our spectator who wants to get live update or all the information, they will go to the matches part. How they will see the score? Let me just add, copy and paste spectator. When you are in the interview, you need to actually do similarly how I'm talking and doing. You also need to do that, communicate, so that interviewer can understand that how you are thinking and they can help you. They normally guide you how you think and get the how to get the outcome. Okay, let me just show you that now spectator wants to get the data. Suppose they reach to the slash match slash ID, how they will get the data? The easy way is having this one here. Kind of similar like score management service or score score displaying service, and it will get the data from the same database. So what will happen here? The score, every time they need to send a request, so they get the next data, send the request, get the next data, which is not expected. They want live data, they don't want to send the request. So this kind of cases, when we want the live data, there are like two ways. One is long polling, like we pull the data every probably every second we send the request, okay, give me this matches live information. That we used to do like probably 15 years ago. Now we don't do that. We have system where we can push the data, push the information. So how can we push this information? Normally we send request then get the response, but now in this case we want live data.
Okay, there's a question and comment. Quick one.
Okay, sure. Need to also connect to participants, so it can attribute scores to players score to, usually by phone, but maybe computer. Need to also connect to participants. Which one actually we're talking about? So it can attribute scores to player scores to, usually by phone.
Paul, you can unmute and ask the question just to clarify.
Okay, sorry about that. I think I was just following along when you were talking about before. The last one was spectators, and I said usually spectators 90%, a lot of times is by phone, but could be by computer.
Yeah.
And then you had needs to connect, so the participants, so the scorer, you had what it needs to connect to. What are all the different attributes? And I was going to say, well, the score management needs to also know the participant. It needs to connect to the participant because it has to know what participants are scoring historically. Because usually you're keeping stats on the participant in terms of the scoring. So
right.
There's overlap here in terms of the score. It's not just like there's overlap between multiple tables that he's going to hit in terms of updating. So it's not just the tournament that's being updated, but also the data of the participants in terms of those who played in the game and those that scored. So the time and so that you keep a stats about the players.
Exactly. That's a very good point. Actually, that's what actually we need to consider. This whenever even for scorer as well, when they score, there are player attached with that. So that means they need to actually communicate with um, participant management service as well. Same thing for spectators as well. When they want to get the information, they need to communicate with the participants, like which player scored what. So all of those users also need to communicate with participant management services. It's a good point. And we can have like same database or different database, but as we want, we can keep it. And this one, when we want to display this score, we need to have something that can push back, like not push back, sorry, push the data. So we need to have another part here that is called WebSocket server. Whenever user is in this page, it wants to watch one match, probably, suppose like one match. Then what it will do, I just put match and match ID, probably 123, whatever the ID is. They came here, they want to know all the scores. Whenever a scorer will update any information, we need to get this information. So how can we get this information? We can have WebSocket. So in first step, we saw that this score displaying service can actually get the data from database and display. And whenever there is a live update, it can actually communicate this with this WebSocket. And what will WebSocket do? WebSocket can handle these things in two ways. One is pulling data from database and then send the data, or it can actually manage the event. Like score management service, whenever they update, it will send this information to this WebSocket server. That, okay, one event triggered and WebSocket knows that, okay, I got one information. Who subscribed my message? This person subscribed my message. Okay, I'm going to send this one to this channel. When communicating with WebSocket, suppose this is a front-end React application or whatever application we use, we create a channel first. And from that channel, we send like bidirectional data. So whenever any data emits from here, it will receive into a score displaying service. And score displaying service will display from that live score that got from WebSocket server. This is how it can actually manage. Like first, like event, this event will go to WebSocket server, and then it will reach to score displaying service. Do you have any question here up to this? I'm going to discuss about the scaling part, but before that, did I miss anything? Any part? Okay, if there is no question or anything.
Doesn't the WebSocket server usually connect to this client, to the client subscribing to the WebSocket rather than a service? Seems sort of weird that you're going from the WebSocket server to another service, because usually the WebSocket's pulling stuff from services or from the database, and it's the actual connection is to the client that's subscribing to the WebSocket, is it not?
Okay, probably the naming is a bit like misguiding.
Right.
Yeah, score displaying service is not a backend service, what I meant to say. This
Okay.
one is the front end one that from the browser or mobile app,
Okay.
it will display this part only.
Okay.
And you're definitely right that client client communicates with WebSocket server. So this is the client. So probably if I put it this way, it will be more easier to see. Okay, it's inside this mobile app and it's communicating with WebSocket server. Cool. Now it comes to scaling part. There was a question there, like WebSocket server. How can actually we can scale WebSocket server? WebSocket server actually has a problem of scaling, but we can do it using load balancer. Same way that we can do, but that is quite complicated one. WebSocket server, they're like definitely we discuss probably like horizontal scaling and vertical scaling. So if it is just few more requests, then vertical scaling probably the way we can do like WebSocket server. But if we want to serve a lot of users, like 500,000 users, and our WebSocket server vertical scaling will be like way more expensive. So it's better to scale it up either using HA proxy load balancer, or we can use PubSub, not a WebSocket server. Here we can use PubSub, and PubSub will actually scale up. We can, if you use the PubSub service from like either Google PubSub or any other tools, then it will scale up according to this, according to the users. So this will be replaced with GCP PubSub, suppose. So this event will be published to this PubSub, and PubSub will check that who subscribed this message. So if there are like thousands of spectators or millions of spectators, if they want information of this match, if the topic matches, then sorry, I think the arrow is wrong. So it will send or push to this client. That's how you can actually manage this part. This is kind of high level, like e like normal way, high level bird's eye view of system architecture diagram. So that's kind of all for today, but I would like to share with you what I will discuss next week. Mainly I'll discuss about like system design for data engineers. Data engineers means like when we get the data from different sources, different formats, how ETL runs, what are the things actually takes this data, transform it, and put it into some other places, are used for machine learning and other parts. So that's one thing I will discuss. I will share with you some resources for scalable system development, microservices, and some people's profile who are like system architect and they have some newsletters. I'll give you some system design interview tips. So probably that will help you to organize your thoughts and uh, make sure that whatever you know, you can actually tell to the interviewer and draw the diagram properly. And if you have any question and answer, we'll discuss about that next session.
Thank you, Perky. There is a question. I'm gonna share our YouTube channel and in the last video. I think it can be found there. Just give me a moment, please. In the meantime, any question from anyone?
I can see there are 2 questions here. First question from Mako, that can you discuss your DB choices for this application? DB choices for this application. Okay. When we have like unstructured data, then we use NoSQL. For structured data, in our case, I can see that we can design the diagram and data will be like same. If we have like similar kind of matches, if we target only one kind of matches for like suppose only badminton or table tennis, then it is quite structured data, and we can keep it into any RDBMS. So my preference normally remains in MySQL and Postgres. So we can use any of those. And sorry. But if we have like different kinds of data, probably cricket or baseball, they have different scores. So most of the cases, those scores are probably cannot be structured properly. So, it can vary match to match. Then we can use NoSQL for that reason. But for our use case, I can see most of the data is structured. And second question is, can we use SSE server side, SSE or web push? Actually, these are the like kind of web sockets way, different way of sending data to push data to client side. So definitely we can use for a smaller part. Definitely we can use these kind of things.
Excellent. So, Furky, are we at the end of the session?
Yes.
All right. Sounds like there are no more questions. Thanks so much. Thanks everyone for joining. And our next session 3, which is the most advanced one, will be same time next week, Monday at 7 p.m. EST. Thank you so much for joining, and we all look forward to having the session again. Thank you so much. Happy holidays, everyone.
Thank you.
Thank you very much. Happy holidays.
Thank you. Bye.